In this video, we're going to look at understanding dimension. Determine whether the following describe a one-dimensional, two-dimensional, or three-dimensional measure. Now, before we answer these questions, we're going to look at this three-dimensional object, this cube, and we're going to find a 3D, three-dimensional, two-dimensional, and a one-dimensional attribute of it. So we can use these ideas and extend them to this problem. Okay, so this cube or box is three-dimensional. We're going to think of this as our starting point, okay? Or maybe you're an ant and you're standing in the corner of the box. Which directions can you move in? Well, there's three distinct directions or dimensions. You can move this way, you can move this way, and you can go up or down. So those are the three dimensions you can move in. And this is our world is three-dimensional. You can think I can walk forward and backwards, that's one direction. I can walk to the right and to the left, that's another direction. And you could jump up and dig a hole and go down, that's another direction, or climb a mountain. Okay, so those are the three dimensions that we can see if we consider this box. Now you may be asking, just to mention it, maybe the ant can crawl up here. That may seem like a whole new direction. But it's not a new dimension. And the reason is this is just a combination of walking up the side of the box and then walking over, which would be this dimension. Okay? So if you can get there by some combination of up, over, and to the right or to the left, then it's one of those dimensions you've already used. So now, that was our three-dimensional measure. Now a two-dimensional measure of this box is, you could say, the surface of the box, or the bottom of the box. Okay. So suppose you're an ant and you're on the bottom of the box. There are only two dimensions you can move in, okay? So now there's no up in the box. If we were looking at the bottom, you can move this way, and you can move this way, okay? But there's no up or down, okay? And again, if you want to get to here, you can do so by a combination of walking to the right and then walking up or down. And then lastly, a one-dimensional attribute. I'll use this edge. If the ant can only walk along this edge, okay, then he can just walk up or down. Okay, there would be no right or left. Okay, there would be no walking into the inside of the box. And this one direction is a one-dimensional measure. So again, I know you can go up or down, but this is just one dimension along a line. So you can think of one direction or one-dimensional as a line. You can think of two dimensions as two directions, and let's think of that as the bottom of the box. And three directions or three-dimensional would be anywhere in the box. So now let's look at these questions and we'll try to relate them to attributes of this box as we go. So first we're asked the amount of tile needed for the bathroom floor. So if you imagine your bathroom floor in connection with this cube, it would be like the bottom of the box, okay? So the tile does have a little bit of height to it. It would go up a little bit. But for the most part, when we're measuring the amount of tile we need, we're measuring the number of squares that would fill up the bottom of the floor, which would look like this. Okay, so this is two dimensions or a two-dimensional measure. So we'll put 2D for short. Okay. Now let's outline the amount of baseboard needed for the bathroom. So I cleaned up this picture a little bit. So we're still thinking of this bottom of the box as the bathroom floor. And the baseboard, I'm going to use a different color highlighter. If this is your bathroom floor, the baseboard is what goes around the bottom of the floor. So notice when I draw that, there's probably a door here somewhere. You need to get inside the bathroom. Okay. But when I draw the baseboard, I am drawing along the line. Now granted, I'm going right and left. Here I'm going up and down in relation to this box. But I never go, the baseboard doesn't go inside the room. Okay, and I could basically draw it with a single line without filling anything in. So that means the baseboard is one-dimensional. Now the amount of paint needed for the bathroom walls. So if we're thinking of this as a bathroom floor, let's think of these as the walls. And let's just look at one wall for now. And let's make it green. Okay, so say, oh, this could take forever, so I'll just, you get the gist. We want to paint this wall green. Now there's actually two ways to think about this. Okay, so looking at the wall itself, notice the wall is two-dimensional. We can go up or down on the wall, and we can go right or left on the wall. Okay, so the wall itself is two-dimensional. But I would also accept another answer here. If you've ever painted anything, you may know that we buy paints in gallons or half gallons. I don't know those jugs. I think they're about a gallon. So if you think about a gallon of paint, it actually has 3 dimensions. You could go right or left. This is the bottom of the paint can. There's 2 dimensions. And the paint can also goes up. Okay. So the amount of paint, if we think of it as the bathroom wall, okay, that would be a 2-dimensional measurement. If we think about the gallon of paint itself, we could say that the amount of paint is 3-dimensional. Okay. Now we have some questions involving a bathtub. So we're going to stop thinking about this as the bathroom, and we're going to think about it as the tub. Okay, so I cleared off our image. So I know this is an oddly shaped tub. It looks like one of those really deep ones. Okay. You might think on the top there's that circle part and you could step in. It's more like a hot tub. Okay. Now first we're asked how many dimensions is the depth of the bathtub. Now the depth is going to be the distance from the top, which I'll draw right here, down to the bottom. Okay. And notice I could have drawn this distance or measured the depth of the bathtub in many different places. Have measured it here, and these lines are supposed to go straight down to measure it. Okay. But wherever I measured it, it is a one-dimensional measure because the measure is going straight up and down. There's only one direction I can move in. So the depth is a one-dimensional measure. Okay. Next, we're asked about a footprint on a bathtub mat. So I made my best attempt to draw a footprint on the bathtub mat. So when you step out of the tub or the shower, lots of time you have that imprint of your wet foot on the bathtub mat. Okay. So how many dimensions does this have? Well, the outside of the footprint itself, we can draw that with a line. But since we want the entire footprint, I would have to color this in. And notice that this has 2 dimensions. Okay. There's an up or a down and a right or a left along the bath mat. So this is a 2D measure. And finally, we're asked about the amount of water that a bathtub will hold. Well, here's our bathtub. So maybe this is an amount of water. Okay. So notice the amount of water has 3 dimensions. Okay. When you first fill the tub, it fills along the bottom, which is these 2 dimensions, but the water also fills up. So it covers the entire surface of the bottom of the tub, and then it starts filling upwards, which is the 3rd dimension. So the amount of water that a bathtub will hold is 3-dimensional.